Welcome back to Advent of Code 2024, day 14. Let's begin. Alright, so... Hello, Quest Opus, welcome in. Have you already done this one? Day 14, Restroom Redoubt. One of the historians needs to use the bathroom. Fortunately, you know there's a bathroom near an unvisited location on their list, and so you're all quickly teleported directly to the lobby of Easter Bunny headquarters. Paused, but happy to go to bed. I see. Unfortunately, EBHQ seems to have improved bathroom security again after your last visit. What happened last time? This is 2016. Okay. The area outside the bathroom is swarming with robots. To get the historian safely to the bathroom, you'll need to find a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile floor in predictable straight lines. To make a list of all robots' current positions and velocities, you make a list of all robots' current positions and velocities, one robot per line. For example, B equals... Okay. Each robot's position is given as P equals XY. Okay. Each robot's velocity is given as V equals XY, where X and Y are given in tiles per second. Yep, okay. The robots are good at navigating over-under each other due to a combination of springs, extendable legs, and quadcopters, so they can share the same tile and don't interact with each other. One, two, what was, wait, so the robots are the ones? But... Why have we got two here? Oh, the number of robots on each tile. Okay, I see. Okay. These robots have a unique feature for maximum bathroom security. They can teleport. Just sharing. Regarding day 13, I learned about div mod, which does an int division and returns the mod value. Yeah. Remembering that for my AOC toolkit and int maths. Yeah, that's quite useful. But div mod gives... Yeah, it gives two values, doesn't it? The quotient and the division, the quotient and the remainder. When a robot would run into an edge of the space they're in, they instead teleport to the other side. Okay. Alright. The historians can't wait much longer, so you don't have to simulate the robots for very long. Where will the robots be after 100 seconds? In the above example, the number of robots in each tile after 100 seconds has elapsed looks like this. To determine the safest area, count the number of robots in each quadrant after 100 seconds. I think I know where this is going. Learned tons from you this past year, so I wanted to share that if you didn't know about it. Yeah, I did know about it, but thanks for that. But I did only know about it in the recent years. I think I often used to just do the two operators separately. Alright, should we just code up what we think they're going to do for part 2 and like change that one? They're probably going to change 100 to like a trillion or something. And I can already see how we actually do that. This is just modular arithmetic, isn't it? So if you... Yeah, okay. We'll code the more advanced version. It's not that hard. Alright, so we want... Alright. New file 14 input. Suppose I can reuse the regex that I did before to extract these. Hello Smab UK. I think this one looks like an easy problem. I'm gonna code up what I think part 2 is without just doing like the brute force thing for part 1. So we'll use some modular arithmetic. Okay, so things I want to copy forward. From before, let's copy the pos class. I've been using this a lot, so that's good. Use that. Pos. For this problem, let's change it to X and Y just to be consistent with what they are using. Scalar mul. Don't think we need that. Yeah. Okay, so 101 tiles wide and 103 tiles tall. Okay. Am I just gonna... We'll just plug these robots into a list called robots. Then do this roughly. So the pattern is going to be essentially this. But we need so that we can have negative numbers as well. So this will be capture group. Do we just want character? Just character. Hang on, I've got to look up regex. Regex. ASCII letter, digit, or underscore. We want to include minus signs, so... I mean, I can just put optional minus, but I'll just do... Just any character, I think it's fine. Which is dot plus plus that p equals that, v equals that. Robots. Hang on. So it'll be px py vx vy equals insert z. We don't have that. Line in f.readlines. Robots dot append. We'll just put a pair. Whoops. Pause. Wait. So it'll be like pause px py, and then pause vx vy. Okay. All right. And then the height is 103. Hello, Waffles and Waffles and Sayup. How's it going? Are you doing Advent of Code yourself? One oh one, 103, 101. All right, so we want to define get destination of a robot given its pause, its vel, and number of steps we want to iterate. Alright, I mean, this is actually splitting into X and Y. It's actually pretty trivial. It's just, and 103 and 101 are prime, I believe, so that doesn't actually matter. But, in this case. Alright, so X equals, so it's going to be pos.x plus vel.x times steps. I mean, we could actually make a mod function for pause, but it would have to be tied to the 103, 101. No, we'll just do the X and Y separately. But that's an interesting idea. Okay, so X equals pause X plus times steps percent M. Is that right? Y equals pos.y plus velocity.y times steps percent N. What were they asking for us to do? Safety factor. Count the number of robots in each quadrant after 100 seconds. Robots that are exactly in the middle, horizontally or vertically, don't count as being in any quadrant. So the only relevant robots are... Okay. Okay. So... okay, well, here we return the destination. Okay. And now... okay. So, for robots, for, let's say, PV in robots, steps equals 100. Is it exactly 100? Yep. Destination equals get dest of PV steps. So we know where it will be. We just need to see what quadrant it's in. If dest.x is strictly... Alright, well we want to, let's say, top left, top right, bottom left, bottom right equals 0, 0, 0, 0. So if dest.x is strictly less than m over 2, so we don't want the middle. If dest.y is strictly less than m, the n of 2, then t top left plus equal 1, else bottom left plus equal 1, else top right, bottom right. Print. So the safety factor is the 4 multiplied together. TL times TR times BL times BR. Okay. Let's try that. No, too high. Okay. Alright, something went wrong. Okay. Let's take a look at robots. Make sure that looks about right. Yeah, we got the minuses. Yep, that seems fine. Let's take a quick look at... Alright, well, we're not using that method. We can take that out. We're not really using pos, any properties of it. Robots. Yeah, okay, so I think we're extracting it fine. M 103, 101. Alright, so get dest We'll give him pause, velocity, steps. These numbers are all within the grid, aren't they? Are they? It shouldn't actually matter. Yeah, okay. Oh, of course. Just before I wrote this else, I was reminding myself, we're not counting the middle. We're not counting the middle. But we do have to exclude the middle with these conditions. Like this. Okay, so that should be... So we said it was too high, so it should be less now. Yep, that's less. Correct. Part 2. During the bathroom break, someone notices that these robots seem awfully similar to ones built and used at the North Pole. If they're the same type of robots, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse for the robots to display the Easter egg? Right. So. Wait, so... Same robots. Robots should arrange themselves into a picture of a Christmas tree. Okay. So, what's this Christmas tree gonna look like? It's not just gonna be a basic triangle. It's gonna be, I mean, the most basic form would be like a triangle, and then the final row is a... Hang on, they gave us 101, 101 and 103. So it's probably... It doesn't really matter. What we really need to detect is... like... when... I don't know. When we get a tree trunk. That's a good property. So when there's something on every... something along the middle. The middle column is fully covered. So maybe we just iterate steps until that happens. Like... It's probably not going to be like in the millions or something. Otherwise you'd have to use some crazy Chinese remainder theorem stuff. Which we did have to use for one problem in the past. Chinese remainder theorem. Fun stuff. But no, I think it's more... This is more of a just like... try some steps until you see it sort of thing. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, let's say we're going to try and find the Christmas tree for just count up, just do this forever, or just, why am I doing like this? We'll just do while true. I don't know. Let's do it like, all right, positions. Robot pause equals robot. Just take the position. So we've got a list of their positions. And then we say while true, we just sort of move them all. So for I in range, then robot pause. We want to say now this is where it would be useful to have a mod method. Still can't be bothered to put it in. We'll just say x equals robot pause I dot x plus robots I velocity dot x and then mod it m, and then we do y equals y percent n. And then replace the pause with the new pause. So, okay, so in this infinite loop, what are we trying to find? The fewest number of seconds. Okay, so we do actually want the count method for seconds in count. We just do this. This is 1 second. And then we would like to check if I don't know. Okay, let's just say S equals set of robot positions if all. So we want pause m. So we want m over 2, the middle, y or y in, so this in S for y in range n. So we want the middle column to be covered. I assume that's at least that's a basic property that the Christmas tree should have. It's not going to have a gap under it or above it. It could, but I don't think so. Break. And then what? Print the tree. I suppose we have to print the tree here. Let's say if all, or we can just do it every time this comes up. Maybe sometimes it won't actually be right. So print seconds. And now we want to just display for y in range n, row equals, so it's going to be dot if pos y in S, else if we want the tree, what are we going to do? Hash. The other way around. So we do a hash if it's for where the robot is, otherwise a dot for x in range m. Oops. Join it up. Oh, what's happened here? Okay. Print the row. Don't break, just run this and see what happens. Hopefully this doesn't take too long. I mean, I don't see a shortcut of looking ahead of time where they're all going to line up, unless that's that. I mean, that's where you use Chinese remainder theorem stuff. But we've got too many robots for that, really. Still possible. Let's try. So we're saying if all Alright, I don't think this is working. Alright, we'll have to relax it a bit. Let's just see what's going on then. Okay, not this. If seconds percent 10 equals 0. So every 10, I just want to see what this looks like. It's so big. I kind of want... What am I supposed to do with this? So the column thing doesn't seem to... work. I mean, it may not be a perfectly symmetrical Christmas tree, right? Alright, what else? What other property would the Christmas tree have? It would be connected, wouldn't it? We could check if the tree is fully connected. And that'll probably be very quick, because most of the time it's actually completely sparse. So they're all completely disconnected. So if I did like a breadth first search or something, it would just be... would just finish immediately. So should I do that? We'll say if... Okay, let's try that. Define is connected for a given set. So let's just do a quick start equals start equals, just pop something out of there. It's using more operations, that doesn't matter. Or should we just not use this set operation? It might be a bit expensive. Let's just not do that. So we've got the list of posers. Now we just want to check if that is fully connected. So just give a list start equals L0 while start so we want what am I trying to do here? Oh, all right, I see. We just need a neighbors method here. Where did I last use that? 12 here. Let's use the version where we're going inbounds. So we want self.x is less than m, self.y is less than n, self plus delta. I took out the addition. We're using that now. So we've got neighbors. Okay. Just say S equals set of L. So we've got a start, we've got the set, and we want to say while start, and we want visited equals another set. So while start, current equals. What? Why did I call it start? No, Q. Q equals while Q current equals Q dot pop. Okay. Part 2 was so confusing for me. Yeah, I still don't know what this Christmas tree is going to look like. So the only assumption I'm using now is whatever it looks like, it's going to be connected. Like, it could be symmetrical and in the middle. But this is not detecting it. Or, okay, I could do one more thing here. Instead of assuming it's going to fully cover the middle, let's just cover a little bit of the middle. So let's say... if all for y in range, let's say 5 up to, hang on, yeah, from 5 to n minus 5. So maybe there's gaps at the top and bottom. Try that. Okay, it's not finding anything. Alright, we'll just do the connected thing. Alright, so it's connected. Okay, so alright equals q.pop. For neighbor in current dot get neighbors. So staying inbounds because we're looking visually, so we're not rolling off the end in this case. Neighbor not in visited. Visitor dot add neighbor. If neighbor in S, that's the important bit, and neighbor not in visited, we visit it, pop it on the queue, and the idea is return if the length of visited is equal to the length of S, then it should all be connected. We might want to relax that condition if there's a gap for the branch or something, I don't know. So if we do this, we say if is connected we'll pause. Try that. Length visited equals length set, which would mean let me read the description again. Most of the robots. Aha. So we do need to relax it. Let's say length visited is greater or equal to length S over 2. That would be most. But it depends where we started. Whoops, okay. Maybe we have to do something a bit. Okay, we have to repeatedly largest group equals 0. Candidates equals okay, so what we actually do is we just keep exhausting this set. How this is going to be an expensive operation. We might have to look for a different way. All right, well, candidates. But then again, it's linear, so it's actually not that bad. Candidates is all the original robots' positions. While we have candidates, we take one of them arbitrarily. Let's say list candidates 0. Make these separate lists. Q equals... Actually, we don't need that. So visited equals... Okay, we can just do this. Q0. While Q current equals Q depart for neighbor owner, if neighbor in candidates and neighbor not in visitor, visitor add, blah, blah, blah. Then after this is done, we say largest group equals max of whatever it was before, and length of visited here. And then candidates minus equal, just remove all the things we've now visited. And return largest group is greater or equal to length of. So they said most of the individual robots, right? So it should be the original number of robots. If the largest group is greater or equal to the length of L, let's say over 2, should be a bit more generous, over 4. Let's see if we get anything. Anything at all? Just divided by 10. Start small. Okay, get me something where they're like 4 of them together. Just give me something. S is not defined. Yeah. Oh, yeah, okay. I don't know. So we can't even find something where 12 of them are together. Oh, this sort of looks like they're coming together. 2057. Oh, something is definitely. Oh, there we go. There it is. 7915. Oh, I see. It's disconnected. The border around it. Alright, so you would need like. So I think this strategy works, but I just need to be a bit more. I need to relax this condition a bit, so it'd be like. Alright, 7915. So it'd be like for the Christmas tree itself. It'd be like length L. Let's go with 4. Maybe I just didn't leave it running long enough. So I'm saying like if a quarter of the robots, so half the robots make the picture, at least half the robots make the picture, that's most. So if a quarter, or let's just be a bit more generous, let's say 8. Let's try that. So it was 7915. Let's try that again with make it more automated. So that might capture it. Length L is what? Oh, no, we don't want L. We want no, because that's gonna be way bigger. Hang on, we want. Alright, I found it anyway. Yeah, so that's fine. Largest group. Yeah, that's not quite... we wouldn't length up the set of L because there could be lots of robots in the same place. Alright, it doesn't matter. 7915. Or should we say... Alright, well, let's change that. I don't want to keep... length. Set of L. Well, I can't keep doing set operations, let's just say. Num equals length of candidates here. So we say num, let's go with 4. All right, try that. So 7915. I just want a final script that sort of makes sense and isn't too hard-coded. Yeah, okay. And then we'll say break. I just looked for 10 in a row. Yeah, that makes sense. And my backup option was to just look for a vertical line segment of, yeah, something like 10, I guess. Yeah. Yeah, that was a good problem. It makes you think a bit harder. And let me just finish this off. Print. Well, we get the seconds. We are printing it there, so 7915. Too low. Am I off by 1 or something? So they said the fewest number of seconds, but if it was too low... for seconds in count... Oh! This starts from 0. Count starts from 0, so it should really be count 1. So we actually want... Alright, let's just run this. Make sure that this... I didn't actually change anything, did I? Run it one more time so we see. Yeah, so my count was starting from 0. So it should be 7916, yeah. So in theory, this Christmas tree would repeat itself, although the period will be massive, so I don't think you would ever... Or you can actually find the period, it's not too difficult. If you find the period of every individual robot, multiply them all together, or you have to find the lowest common multiple or whatever, but then... Well, I mean, they're prime widths and heights, that helps. You could actually find the second time that Christmas tree appears, although it's going to be massive, I think. But yeah, in theory, that Christmas tree should keep repeating itself infinitely. Alright, so yeah, that was a clever problem. Bit more of a investigative type of problem. Certainly harder for people to cheat on with AI. This needed a bit of experimenting. My friend director said, they want to make a picture of all robots and no one should overlap. I see. Yeah, sometimes they've had problems involving ASCII art. Like there were a couple where the answer was a number that was written in ASCII art, so you had to actually find and print the ASCII and read the number off. I think after I had solved all those problems myself, I was trying it with ChatGPT to see what it's actually capable of, and I think ChatGPT actually started putting together a digit detection, like an OCR algorithm. So it was like detecting shapes and seeing like their similarity to the number 1 and number 2. It was actually putting together an actual detection thing to actually automate that process, so you didn't have to look at it by eye. It didn't quite succeed, but it was quite cool that it thought of that. And so yeah, AI can still do it, but it's harder. I thought they may possibly make baubles by having more than one robot in a position. Oh, interesting, yeah. Add weight to the baubles. All right. So, okay, I don't normally... Lately, I've not really been looking at the global leaderboard, but I'm just curious in this case. 12 seconds... Okay. I mean, the first problem was really simple, but that's still quite fast. Both problems 2 minutes 13, so that is actually more plausible. If they thought of just like look for 10 in a row or something like that, or then I don't think Eric is doing anti-LLM puzzles. Normally one of the puzzles per year is that style. Yeah, I agree. He's done them in the past like that. Although, even before LLMs, like this type of problem is good for avoiding cheating by like copying or googling answers and stuff, because it involved you to actually have to figure things out, and there's no simple algorithm which gives you the answer. You have to sort of do a bit more investigation. So even before LLMs, I think this was a sort of problem he liked adding, because it wasn't quite as straightforward. But yeah, it's not necessarily an anti-cheating device, but it does function as a sort of anti-cheating device, an anti-googling device. This is one of those days when I'm happy with my code, yeah. I think Captain Coda said he wants to start catching up. But I don't know if he'll actually stream these recent days. Alright. We are over halfway through the month. That's cool. Second part runs under 0.5 seconds. Yeah, I suppose you can... I'm wondering if there's a way to avoid simulating every step. Not really. I mean, you can sort of jump 5 at a time or something to see if the robots are coming together, clumping together a bit. There's no point doing that, really. see anyone doing this problem. Well, this one's in Python. Are they doing Advent of Code? Yeah, I think they are. Okay. But it's not. Oh, they're doing the antenna problem. Alright, well, they're the only one doing Advent of Code, so... Takes just over 2 seconds to run through all of the days so far. Nice. Alright. I'll be back tomorrow. We still haven't had any real stumper of a problem that takes me like 5 hours to solve. There's always been at least one in past years. We'll see. It's been really generous. Like the other day I was just saying that that problem which I use Z3 for, yeah, I mentioned in the Discord, there is kind of an edge case where the two vectors are parallel, which induces infinite solutions. That never came up in the inputs, so and that was a prime opportunity for him to trick us, but he didn't. Alright, thanks for watching, everyone. See you tomorrow or in following days. Michael PC Gamer is working on... Oh, okay. Well, we'll raid Snowcone. I think I've raided Michael before. Or I might not have, but I think next time. Alright, see you next time. Bye-bye.